Now I'm going to work on adjustment of the MFC. We saw from our initial test of the mass flow controller that it was out of tolerance at a few points, and we want to do manual adjustments to bring it back into tolerance. For my adjustments, I'm going to use Compass and its run DUT mode rather than run test. Under the run menu, I'll choose run DUT. In this case, it boots into a mode where we can take live real-time readings out of both the device under test and the MOLBLOC and adjust the MFC to match the MOLBLOC reading. This can be done just as easily using the front panel of the MOLBOX and just taking those readings live instead. I'll select the MFC as my device under test, a few default options, and now Compass is initializing. We almost immediately get readings out of Compass, and we see a reference indication and a device indication up at the top. The goal we're going to have is bringing the error as a percent full scale, shown here where my cursor is, within 1%. I remember during our initial test we were about negative 0.5% of reading on the initial test. Now to make the adjustments, I'm going to finish removing the cover from the MFC so I can access the potentiometers to make adjustments. I'll replace the MFC cable so it can communicate with the MOLBOX 1 Plus. I've identified 3 potentiometers that adjust the MFC's reading at 0%, 50%, and 100% points. Depending on procedures you have, you may need to or want to close the isolation valve and remove pressure from the MFC or even cap off the end of the MFC. I think since we're using not control set error rather, and we're using measurement error, I can just as well take the reading just like I did during the automated test, which is to allow the MFC's valve to close off the flow as best it can and compare the measurements between the MOLBLOC and the MFC as they are. So right now both of them are a little less than 1 sccm, and to adjust the MFC I'll turn the 0 potentiometer and bring its reading closer to the reference indication. So you can see now that the percent full scale error has reduced. In a lot of cases at these low flows it will require some waiting and some patience. I'll adjust this until my error is well within our tolerance of 1%. Okay, I've made an adjustment at the 0 point, and it looks like we have a reduced error. We could give that some time to settle out, but it looks like it's going to be improved upon where we started. So now I can bring up my set flow dialog on the Compass window and type in my next point. Now the proper operation of making these adjustments would be to next set the 100% or 50 sccm test point. So I've set my flow. You can see the device under test reading is there, the reference indication is coming up. If I give them a few moments to stable out, we'll be able to make that adjustment as well. The 100% point was actually well in tolerance on our test run as well. Okay, now we have some adjustments to make. Looks like our 0 adjustment has had an influence on the 100% point. And so you can see that the device under test, the mass flow controller, is adjusting its flow to what it thinks is 50 sccm as usual. And since it's in error right now, the reference indication, or the MOLBLOC flow, is reading 49 sccm, or below 49 instead of 50 sccm. So as I make the adjustment to the MFC, you'll see this number here change, the reference indication. You'll also see this percent error change. That reference indication is slowly coming up. We see the error now starting to come inside of 1%. And there we are, well within our tolerance. Next, we have to check the 50% point, which is 25 sccm. I'll enter that into Compass, and again, give it some time to stabilize. As always, the more time you can give it for stabilization, the better your data and more repeatable your adjustments are going to be. At these very low flows, it tends to take additional time. Our worst point during the initial run was at the 50% point, where we were high by over a percent, almost 1.4%. So I'm going to need adjustments on this point to bring it down quite a bit. Again, I'm watching that error percent full scale indication next to the cursor and bringing that down to within 1%. Okay, that 50% adjustment will adjust the linearity of the MFC. Let me take another check up at the 100% point to be sure we're still in intolerance there. And it looks like it's still pretty good. After we're satisfied that we have all our adjustment points in tolerance, then we can go back to Compass and rerun our automated test like we did in the beginning and gather data to be sure that our as left condition is in tolerance on the MFC.